Students, let us discuss about isomerism. Isomerism in coordination complexes. Coordination complexes. There are two kinds of isomerism broadly. That is, one is we have structural isomerisms. Structural isomerism. Second one is we have stereoisomerism. Stereoisomerism. So in the case of structural isomerism, in turn, we have different categories. See, stereoisomerisms, we have two classes. We know that. One is we have geometrical isomerism. So another one is we have optical isomerism. So two kinds of isomerism, one is geometrical, one another is optical. In the case of structural isomerism, we have, it can be subdivided into different classes. That is, we have ionization isomerism, simple one, this is ionization isomerism. And we have hydrate isomerism. Hydrate isomerism. We have something called, the ionization isomerism, hydrate isomerism. We have linkage isomerism. And finally, the coordination isomerism. So, I'll repeat again, structural isomerism can be broadly subdivided into ionization, hydrate, linkage and coordination. They may directly ask the question here, which of the following shows linkage isomerism, or which of the following is an example for the hydrate isomerism, so on and so forth. This is an easy part. Next one is we have stereoisomerism. Two categories we have, geometrical and optical. We will be dealing with tetrahedral, octahedral as well as square planar complex. So, different kinds of the complexes which can show the geometrical isomerism and the optical isomerism in detail. So, let us just rush through the structural isomerism very quickly. There is no much to study in the structural isomerism. Ionization isomerism. For example, what happens is the ions produced will be different. Molecular formula is same, but the ions produced will be different. Ions produced will be different. In this case, ions produced will be different. That's it. So, for example, if you are having, the cobalt complex, I will take it. Cobalt, pentamino cobalt complex I will take, and Br is the complex, or sulfate. Anything can be taken. Doesn't matter. Sulfate is the complex. So, how do you name this complex? Pentamino chloro cobalt 3 sulfate, actually cobalt 3 sulfate. So, this particular complex you can write it in other way around also. For example, CO, instead of sulfate outside, I can write sulfate inside and chlorine outside. So, how does the ion will be formed? If you put this in the solution, what and all ions will be produced in this case? Pentamino, right? Cl 2 plus is the ion produced, plus SO4 minus 2 is the ion produced. Here it is CO pentamino, right? SO4, right? Plus charge plus Cl minus. See, kind of the ion produced will be different, but both having the same molecular formula. In one of the case, sulfate ion is there outside, chloride is inside. In another case, chloride is outside, sulfate is inside. But it is an ionization isomerism, because the ions produced in solution will be different, although the molecular formula is same. Although the elements, although the ligands as well as the the counter ion participated looks to be same, molecular formula is same, but the ions produced in the solution will be different. So, this kind of the isomerism is called as ionization isomerism. We can take plenty of examples for that matter. For example, platinum complex I will take it, Cl2Br2, this is the complex I am taking, right? So, instead of bromine outside, I can make it as like platinum pentamino Br2, right? Cl2 will be outside. So this can be the option, right? That is, in the first case what is happening is bromine is outside. In the second case the chlorine is outside. So how the ions will be produced in this case? Ions will be produced as Pt pentamino, right? That is Cl2, right? Plus 2 charge plus 2 Br minus in the first case. Second case is Pt pentamino, Pt pentamino, right? Br2 is inside with the positive plus 2 charge and 2Cl minus. Are you getting my point? What I am trying to say is, in the first case the ion produced will be this plus 2 Br minus. Second case the ion produced will be this plus 2Cl minus. That means it is different ions produced, although the molecular formula is same. So this kinds of isomerism is what is referred as ionization isomerism. Clear? So they may ask you what kind of isomerism shown by this kinds of complex. So it is ionization isomerism. Done with the ionization isomerism, we'll go for hydrate isomerism. For example, I'll take COCl3, 6 water molecule, I'll take it. COCl3, 6 water molecule, I'll take it. In this particular complex, if you consider number of water molecules as a ligand and number of water molecules outside the sphere, or what is called as water of hydration. Water of hydration and the water of ligation, right, will be different in this case, right? For instance, I am taking COCl3, 3 water, COCl3, 3 water, right? You can write it as COCl3, 3 water, or I'm sorry, COCl3 water thrice, right, with the 3 water molecule outside. This can be the one of the option. So in one of the option, what we have done is 3 water molecules are inside, 3 water molecules are outside. This is water of ligation, that is water which is involved as a ligand. This is water of hydration, that is water which is involved as a hydration, for hydration. This is water of hydration and water of ligation. Water of hydration here, water of ligation here. So one same molecular formula, I can write it in other way around also. COCl2, 4 water molecule, I will put it inside. 4 water molecule, I will put it inside. In a way, 1 Cl will go outside. Now, Cl dot 2 water. How many water molecules are there inside and how many water molecules are there outside? The water molecules there outside are 2 and water molecules there inside are 4. I mean, the number of the water of hydration is different now. So, COCl water 5 times, right, octahedral complex, all are octahedral complex, Cl2 water. Are you getting my point? So the important thing is, what is observed is water of hydration and the water of the ligation will be different, although the molecular formula is same. Such kinds of isomerisms are called as hydrate isomerism. Whenever the water comes into the picture, and if at all they are asking what kind of structural isomerism the coordination complex exhibit, if at all they are asking, it's very simple, you just put it as water. Hydrate isomerism, we can just put it as it's hydrate isomerism. It's nothing but the number of water molecules which will be there inside as a water of ligation and the water of hydration will be different, although the molecular formula will be same. So the next one is you have a linkage isomerism. Linkage isomerism is, for instance, I will take a complex, students, for example cobalt complex, I will take it, nitro NO2, ammonia 5 times, right, Cl2, I will put it outside. Okay, it's a cobalt plus 3 complex. Cobalt in, the plus 3 oxidation state, NO2 minus and Cl2 minus, 2Cl minus. But the important thing is, using the same molecular formula, I can put it in other way around also. I can write it CO, ONO instead of writing NO2, ammonia 5 times octahedral complex Cl2. Same one I am writing in different way, that is instead of writing NO2 I have written it ONO. Or in other words, what I am trying to say is, in this case, nitrogen is linked to the cobalt atom. That is, nitrogen is the one which is giving the lone pair of electron to the central atom. In the second case, oxygen is the one which is giving the electron to the cobalt atom. or in other words, the link is different. The way in which the coordinating atom which is linked to the central metal atom will be different, or central coordinating atom which is getting linked to the central metal ion will be different, or in other words, this is a linkage isomerism. This is a linkage isomerism. This is linkage isomerism. That is, the nature of the coordinating atom which is linking to the central atom will be different. In this case it is nitrogen, in this case it is oxygen. So nitrogen is getting linked in the first case, second case oxygen is getting linked, right? So this complex, how do you name? That is pentamino nitro cobalt 3 chloride, whereas this is pentamino nitrito, right, cobalt 3 chloride. Why? Because the oxygen is getting linked, right? In this case the coordinating atom is oxygen, in this case the coordinating atom is nitrogen. Or the linkage isomerism is possible, can I say, only when you are having ambidentate ligand. When you are having ambidentate ligand, then there is a question of linkage isomerism. See, which of the following shows linkage isomerism? If at all they are asking, just look for whether there is a ambidentate ligand or not. Ambidentate ligand is NO2 minus is an ambidentate ligand, not NO3 minus. NO2 minus, because nitrogen is having lone pair of electron. You can write the structure like this. Nitrogen is having lone pair of electron. Oxygen also can involved in the donation. That means, it's a monodentate ligand, but the two coordinating atoms are there. At least one of the coordinating atoms will be utilized for making a coordination bond with the central metal atom. So the nitrogen can also be linked, or the oxygen can also be linked. Nitrogen can also be linked, or the oxygen can also be linked. SCN minus, if you consider nitrogen, or the sulfur can be used. Got it, right? Or Cn minus, carbon can be utilized, or nitrogen can be utilized. CO, oxygen can be used in linking, or carbon can be used in linking, and so on and so forth. We have plenty of the ambidentate ligand. You have Cn minus, CO, Cn, the NO2 minus, and so on and so forth. Number of ambidentate ligands are there. What I mean to say is, I am trying to say is, so whenever you are having an ambidentate ligand, the linkage isomerism is possible. Water is the main priority here, water of hydration and the ligation. Here, it is the priority. The important thing is you need to have an ambidentate ligand. If at all they are asking what kind of isomerism is shown by ambidentate ligand, right? What kind of isomerism is shown by particular complex? If at all you find an ambidentate ligand, that means it is the isomerism is a linkage isomerism. And the last one is we have coordination isomerism. Coordination isomerism is both cation as well as the anion part is a coordination complex. Both cation as well as anion part is a coordination complex. For example, cobalt complex I will take it, and chromium complex I will take it. Cobalt complex and chromium. So I am sorry, this is both are octahedral complex, ethylene diamine. So chromium complex and cobalt complex. See, look at here. This is the positive part of the the complex. This is the negative part of the complex. But both are the complex spheres are there. So they can have an exchange. The ligand can be exchanged, students. Instead of ethylene diamine here, you can shift the ethylene diamine here to the chromium, and cyanide can be shifted here. So one more way to, the isomer can be written as Cn 6 times. So Cn went to the cobalt side, and Cr will take ethylene diamine thrice. So this is the complex, that is, which exhibit coordination isomerism. Clear? So in the coordination isomerism, the ligand which will be linked to the positive part of the complex ion and the negative part of the complex ion will be exchanged. So such kinds of complexes are called as, such kinds of isomerisms are called as coordination isomerism. Very simple. So this is about the structural isomerism, students. We'll take a look at the stereo isomerism. We'll take a look at the stereo isomerism.